As AI becomes integral to software, developers must address its ethical implications. Bias, unfair outcomes, and over-reliance on automations are risk. Embedding principles like fairness, transparency, and accountability throughout development ensure AI systems are not only effective but also socially responsible and aligned with user trust and expectation. Hello everyone and welcome to my channel Cloud Container Code and AI. I'm Gautam and I bring over 20 years of experience in designing, managing and supporting Microsoft enterprise services. In the next 12 minutes, we'll explore how Microsoft promotes a set of responsible AI principles that guide ethical and effective AI development. These principles include fairness. Under this principle, AI systems should treat all individuals equally, avoiding bias and discrimination. Next principle is reliability and safety. Reliability and safety principle says AI must be robust, secure, and perform consistently under various conditions. Next principle is privacy and security. For privacy and security, responsible AI principle says protect user data and ensure compliance with privacy regulation. Next principle is inclusiveness. Developer must design AI to accessible and beneficial to diverse communities and individuals. Next principle is transparency. Under transparency, we need to make AI system understandable and explainable to users and stakeholders. And the last principle is accountability. This is very important principles. Here, these principles ensure clear responsibilities for AI decisions and their impact. Together, these principles help ensure that AI systems are designed and deployed in a way that it minimizes harm, promote trust, and deliver meaningful benefits to user and safety. Let's dive in and understand how each principle shape the future of responsible AI. Fairness in AI system is a critical design consideration. When developing machine learning models such as those used in loan approval applications, engineers must ensure that predictions are made without bias related to gender, ethnicity, or other sensitive attributes. Unfair outcomes can lead to discrimination and loss of trust, especially in high-stake domains. Although tools exist to evaluate, quantify, and mitigate bias, fairness cannot be achieved through tooling alone. It must be embedded into entire development life cycles. This includes careful curation of training data to ensure it is representative of all relevant user groups and continuous evolution of model performance across different population segments and proactive design choices that anticipate and address potential source of unfairness. In a summary of fairness, I can say that AI systems should treat all individuals and groups equally, avoiding bias and discrimination. Fairness ensures that outcomes are not skewed against people based on race, gender, age, or other protected attributes. For example, a hiring algorithm should evaluate candidate based on qualification and experience, not on demographic factors. If the system not behave properly, not behave impartial, or favoring one gender, it violates fairness. Next principle is reliability and safety. In reliability and safety, it's ensuring that AI system is essential, particularly in high-stake domains like autonomous vehicle or healthcare diagnostics. In such context, system failure can pose serious risks to human life. As with traditional software, AI application must undergo rigorous testing and deployment process to validate functionally and performance before release. However, AI introduced additional complexities due to the probabilistic nature of its machine learning models. Engineers must account for uncertainty in the predictions by setting appropriate confidence threshold and evaluating models' behavior under diverse scenarios. So this includes stress testing models with edge cases and monitoring for unexpected results or outputs. Reliability also involves continuous validation post-deployment, especially as data distribution shifts over time. By embedding robust testing strategies and safety checks throughout the development lifecycle, engineers can build a system that not only meet functional requirements but also afford safety standards and user trust in real-world environments. For example, an autonomous vehicle must reliably detect pedestrians and other vehicles in various welfare conditions. A failure to recognize a person crossing the street due to fog would be a safety issue. In a summary, I can say for reliability and safety, a system must function as intended, under all expected conditions and be robust against error or adversarial attacks. Safety also includes that ability to fail gracefully and not cause any harm. Next is privacy and security. Privacy and security are essential pillars in AI system design, especially given the data-intensive nature of machine learning models. These systems often rely on large datasets that may contain sensitive personal information. And these are making robust data protection measures critical. Even post-deployment, AI models continue to process new data for all predictions or actions, which can introduce ongoing privacy and security risk as well. Engineers must implement a safeguard such as encryption, access controls, and anonymization techniques to protect data user throughout the life cycle. Additionally, compliances with data protection regulation like GDPR and secure model deployment practices are vital. Privacy preserving techniques like differential privacy and federated learnings can further enhance protection by embedding security and privacy consideration into every stage from data collection to inference. Developers can ensure AI systems are not only effective but also trustworthy and compliant, minimizing exposure to data breaches and misuse. For example, a voice assistant should not record conversation without consent, and any stored data should be encrypted to prevent unauthorized access. In a summary of privacy and safety, all AI must protect user data and ensure that personal information is not misused or exposed. Systems should comply with data protection regulation and implement strong security measures. The next principle is inclusiveness. Inclusiveness is a core principle in responsible AI development, ensuring that system benefits all individuals, regardless of physical ability, gender, ethnicity, or other identity factors. To achieve this, engineers must intentionally design a system that are accessible and equitable across diverse user groups. A key strategy is incorporating input from a broad spectrum of stakeholders throughout the development lifecycle, spanning design, data collections, testing, and deployments. This helps identify and mitigate potential exclusionary patterns or usability barriers early on. Inclusive AI also involves evaluating a model performance across demographic segments and ensuring that user interfaces accommodate various needs such as assistive technologies. By embedding inclusiveness into both technical and human-centered process, developers can create AI systems that are not only functionally robust but also socially equitable, fostering broader adoption and trust. Ultimately, inclusiveness is not just a design goal. It is a continuous commitment to building AI that serves everyone. In an example, I can say that a speech recognition system should understand different accents and dialects to serve a global user base effectively. So in a summary of inclusiveness, AI should be designed to be accessible and usable by people of diverse background, their abilities and needs. Inclusiveness promotes equal participation in benefits from AI technologies. Next is transparency. Transparency and understandably are essential in AI system design to foster user trust and informed engagement. Users should be clearly informed about the system purpose, operational logic, and limitations. For machine learning based application, developer must communicate factors influencing prediction accuracy, such as training data volume, inferential feature, and confidence score. This helps user interpret output appropriately and understand the model's reliability. When personal data is involved, such as facial recognition system, it is critical to disclose how data is collected, processed, stored, and accessed. Clear documentation and user-facing explanation should accompany a system to demystify complex algorithms and ensure ethical data usage. By giving priority to transparency, engineers enables users to make informed decisions, identify potential risk, and maintain control over their data. Ultimately, understandable AI systems are not only more usable but also accountable, aligning technical performance with ethical standards. For example, a loan approval system should provide reasons for denial of loan, such as insufficient credit history, rather than giving a message that you're not eligible type of message. In a summary of transparency, AI systems should be understandable and explainable. Users should know how decisions are made and be able to question or challenge outcomes. The last and an important principle is accountability. Accountability in AI development is essential to ensure systems operate ethically and legally. Despite the autonomous nature of many AI applications, responsibility ultimately lies with the developers and designers who train models, validate outputs, and define decision logic. These professionals must ensure that AI systems meet clearly defined standards for responsible use. To support, the organization should establish governance framework that guide AI development through documented policies, ethical review process, and compliance check. This includes assigning ownership for model behavior, maintaining audit trails, and enforcing accountability across the lifecycle, from data sourcing to deployment. By embedding accountability into technical workflows and organizational structures, developers can ensure that AI systems are not only performant but also aligned with social expectations and legal obligations. This approach fosters transparency, mitigates risk, and reinforces trust in AI technologies. For example, if an AI system wrongly denies healthcare benefits, the organization should have a clear process to investigate and rectify the error, including human oversight. So in a summary of accountability, I can say developer and organization must take responsibility for the outcome of AI system. There should be a mechanism to audit, monitor, and address issues when they arise. In an overall summary, I can say that the building AI system responsibilities must be foundational principle, not an afterthought. From ensuring fairness and inclusiveness to uphold reliability, safety, privacy, transparency, and accountability, each aspect defined deliberate engineering choices and ethical foresight. Responsible AI is not achieved through tools alone. It requires a life cycle approach, continuous evaluation, and a commitment to governance framework that align with legal and social expectation. As developer, we are not just shaping technologies, we are shaping its impact on people and the world. By embedding responsibilities into every layer of AI development, we can create systems that are not only intelligent but also trustworthy, equitable, and aligned with human values. Thank you for your time. If you have any questions, please let me know. And thanks again. Thank you.